So today we're doing radical equations. We're going to solve them, which is very, very simple. So if we look at example 1, if I asked you to solve this, it would be really simple if there wasn't a radical there. So let's get rid of the radical. How do you get rid of radicals? You just do their inverse operation. So since this is a square root, I'm going to square to get rid of a square root. X plus 4 equals 400, minus 4 from both sides, and x equals 396. And you can check it. 396 plus 4 is 400. The square root of 400 is 20. Not that hard today. So here are your steps for solving radicals. We want to always try and get the radical alone. That way we can undo it with its inverse operation. Now, how can we get the radical alone? We could move terms to opposite sides. We can cross multiply to get a radical out of a denominator. And it can mean moving radicals to both sides of the equation if we see two radicals. And then we just inverse operation. Square both sides to get rid of a radical. Or, actually I shouldn't say square, because sometimes we'll have to raise things to the third and the fourth power. But be careful of binomials, because when they are squared, they become trinomials. All right, so here's example 2. This says, find this equation when the square root of 2x plus 3 equals the square root of 4x. So using my little menu over here to how to solve, I need to isolate the radicals. They're isolated. That means moving radicals to both sides of the equation if there are two radicals, and that's what we have here. Inverse operations, we're going to square both sides. So if I square this side and I square that side, how simple is it? The square and the square root cancel each other out. The square and the square root cancel each other out. X equals 3/2. And we should always check to make sure our answer works, because as we found out the other day, sometimes we can come up with a fake answer, so to speak, that when we put it back in, it doesn't really check. So 2 times 3/2 plus 3 equals 4 times 3/2, and they both have radicals. So the 2's cancel out. 3 plus 3 is 6. 2 goes into 4 twice. 2 times 3 is the square root of 6. Great, this one checks. Okay, example 3. So we see a radical, so we need to isolate it. This can mean moving terms to opposite sides. That doesn't seem like it's going to work here. This can mean cross-multiplying to get rid of radical out of the denominator. Yep, that's what I'm going to do here. I'm going to cross-multiply. So if you have to put that with a 1, so 1 times 25 is what I get when I cross-multiply one side. When I cross-multiply there, I get 5 radical 3x minus 1. Now I'm going to do one more step. These are connected by multiplication. So I can divide by 5 both sides and make it easier. Square both sides to get rid of radical. That's what I'm on. I'm on step 2. So I'm going to square this. I'm going to square that. I get 25 equals 3x minus 1. It's 26 equals 3x. X equals 26 over 3. Now I'm going to check myself to make sure that this works. 25 over square root of 3 times 26 over 3 minus 1. The 3's cancel out. 26 minus 1 is 25. The square root of 25 is 5. 25 divided by 5 is right. 5 does equal 5. It checks. Look at example 4. Wait a second. Isn't that just like example 3? When I look closely now, this is what I talked about. This is a cube root. But I'm still going to follow all my steps. I'm going to isolate the radical. Okay, and we know this was step 2, cross multiplying. So we know if we cross multiply, we got 25 equals 5 cube roots of 3x minus 1. But now, instead of squaring both sides, we're going to raise both sides to cubes. That's how I get rid of a cube root. Well, first I'm going to do what I did on the other side. I'm going to divide by 5 to make my numbers as small as possible. And then I'm going to raise both sides to the third power so that the third power and a third root cancel each other out. Okay, 5 cubed is 125. And I'm left with 3x minus 1. Add 1 to both sides. I get 126 equals 3x. That can get divided by 3. So we're going to have a nice, beautiful answer of 42. I'm going to come over here and check myself. So 25 over the cube root of 3 times 42 minus 1. Well, 3 times 42 is 126. The cube root of 126 minus 1 is the cube root of 125. And the cube root of 125 is 5. 25 divided by 5 does get me 5. So my answer checks. And the last one, isolate the radicals. This can mean moving terms to opposite sides. It can mean cross multiplying. I don't have any fractions here, so it's not going to be cross multiplying. Moving radicals to both sides of the equation if there are 2 radicals. And that's exactly what I'm going to do here. I'm going to take the 3x minus 6 and keep it on the left, but I'm going to take this radical 7x minus 1 and move it to the other side, making it negative. Inverse operation. I'm still going to square both sides. Square and a square root cancel each other out. Now notice what happens here. The square and the square root cancel each other out, and when I take a negative and square it, it ended up being positive anyway. All right, I'm going to clean this up. Add 1, 5. X equals 5 over 4. Once again, I'm going to check to make sure it works. So 3 times 5 over 4 minus 6 plus 7 times 5 over 4 minus 1. When I do that, I should get 0. Well, let's see. This becomes 15 over 4 minus 6. So that is, let's make that 24 over 4 because that's 6. So 15 minus 4 is negative 9/4 square root. Plus, what do I get over here? 35 over 4 minus 1. Make that 4 over 4. So 35 plus the square root of 31 over 4 equals 0. Well, I can't take the square root of a negative number. I guess. Well, you know what, guys? This is why you check. Because the answer here is the null set. There are no x's. And that's because when you take the square root of something, it's always positive. So how can a positive plus a positive ever get me a 0? Never. And there's 2 ways to check this. We could check it on mathway.com or we can check it via graphing. So I'm going to go over here to Desmos. And I'm going to type it in. And I'm going to type in square root 3x minus 6. There it is right there. What's the other one? 7x minus 1. And down here, I'm going to put the square root of 7x minus 1. And if you look, if I bring these over here, my two graphs are never going to cross. There's no place where they ever cross each other. And that's what would happen if I'd set them equal to each other. So indeed, there is no answer to this question. And that's why you always have to check.